Hi, my name is Lectra. This is going to be a simulated lesson for my Math for Teachers class. In this lesson, we're going to assume that I'm teaching 7th graders and not in my living room. I'm going to teach about the components of circles and how to identify and solve them. This lesson is based on the grade 7 knowledge and skills, expressions, equations, and relationships. The student applies mathematical process standards to solve geometric problems. The student is expected to determine the circumference and area of a circle. Let's begin by defining a circle. There are several different definitions that I've seen in tests. So here are just a few. The collection of all the points in the plane that are a certain fixed distance away from a certain fixed point in this plane. The shapes with all points are the same distance from its center. The set of points that are equidistant from a special point is the center. A two-dimensional shape made by drawing a curve that is always the same distance from a center. The set of all points on a plane that are fixed distances from the center. I think my favorite is going to be this one, the two-dimensional shape made by drawing a curve that is always the same distance or equidistant from a center. Equidistant is a key word here. It's used all the time on tests. It pretty much means that if you draw a circle and put a point in the middle and draw lines from that point to that edge of the circle, in theory, all of these lines are the same length because they are equal distance from the edge to the center of the circle. Another thing I wanted to mention is that there are no vertices or lines like there are in a square on your circle. It's a continuous line. It's made of arcs, creating that continuous line that meets in 2 points. So these two, in theory, meet perfectly on the circle, and there's no points or anything. The next point I want to make is measurements of a circle. They're pretty easy. There's 3 main ones. There's quite a few others, but these are the ones we're going to discuss today. We have radius, diameter, and circumference. Radius is the distance from the center of the circle to any point on the circle. So those lines that I was drawing earlier that are equidistant, they are the radius. Diameter is the distance all the way across the circle, so from one side to the other, cutting that circle in half is the diameter. Circumference is the distance once around the circle, or its perimeter. So if you start here and walk all the way around and end up right here, you walk the circumference of the circle. An easy way to remember this is that radius is the shortest word. So it's going to be a short line, and it's going to be the smallest of the numbers. Diameter is a little bit longer, so it's a longer word, longer line. Circumference the longest word, longest line. So the next thing I want to discuss is pi. What is pi? Pi is a numerical constant that represents the ratio of circles' circumference to its diameter. It's an irrational number, which pretty much means that the decimals go on forever and you can't represent it as a fraction. Generally when we do math, to simplify it and make it easier for us to do the math, we just use the first 2 parts of that decimal, so it's 3.14 for calculations. So when do we use pi? Pi is used in all of the formulas pretty much that we need to know for our circles. On the test, you're going to be given a star grade 7 mathematics reference materials, and it has all the formulas you're going to need except for one. So that's the first one we're going to have to talk about, because that one's the one you're going to have to remember. Diameter is 2 times the radius. That one's super easy because we just discussed that it's the medium-sized line, so it's going to be 2 of that radius. Circumference is the second one that we're going to talk about. It's right here on this reference materials. It's 2 times pi times the radius, or pi times the diameter. Depending on what you're given, it might be easier to do the pi times the diameter formula. Area of the circle is the third thing that we're going to discuss, and that one is pi times radius squared. So now that we know all the basics that we need to know, we're going to do some examples and put all this knowledge together. For our first circle, we have a radius of 5 meters. So if the radius is 5 meters, the diameter is 2 times 5, so that would be 10 meters. For circumference, the formula that we're going to use is the 2 pi r for this one. So 2 times 3.14 times the radius being 5. So for this, we could either just put it into the calculator like this, or you can simplify it to 10 times 3.14. I'm just going to type it into the calculator as we see it. So 2 times 3.14, close parentheses, and then times 5. So we're going to get 31.4. Meters, and where's that? So for our second example, the diameter is 4 meters, so diameter was 2 times the radius. So if our diameter is 4, that means our radius is 2, because it's 4 divided by 2. Circumference, so we have our diameter, so I want to use the diameter formula, so that was just pi times the diameter. So 3.14 times 4. And when you type that into a calculator, 3.14 times 4, that brings up 12.56. So our circumference is 12.56 meters. Okay, so the last thing we're going to discuss was the area of the circle. Area is the pi r squared. So if we're looking at this circle, the radius was 5, so it would be pi 5 squared. So area equals 3.145 squared. And you put it into the calculator just like that. So if we do that, we have 3.14 times 5 squared. And that gives you 78.5 meters squared. So for our second example, the diameter was 4, so that, remember, our radius had to have been 2, because that would be half of the 4. So area is pi times 2 squared, so 3.14 times 2 squared. And when we put that into the calculator, you get 12.56 meters squared. So now that we've discussed what a circle is, what pi is, how to use them in those formulas, all that good stuff, I would probably hand out a worksheet that asks like what area, radius, diameter, circumference, and all that of each of those circles are, and then I'd probably give them a reference materials page just so that since we're still new to the formulas, they can reference the formulas that they need to know. For SPED and like ESL students, the only accommodation that I can think of is to walk around when the students are working using their reference materials and just clarify with the students that need it, that they understand, work through the problems one-on-one for a couple times if they need that help. But because everybody's given the reference materials, they shouldn't really need any other accommodations. this concludes my presentation about the circles and all the good stuff that has to do with it. Thank you for watching.